Okay, so the last task for you is to conduct a sensitivity analysis. So what you do here is to get the relationship between cost of equipment and NPV and see how sensitive is the NPV changing to cost of equipment. And then you do another time for water price and see how NPV responds to the change of water price or price per unit. So in the capital budgeting table we have created before, so I want you guys to basically get two tables, okay, additional tables, and this time I want you to do the changes, okay, from negative 30% to negative 20% to all the way to 10, 20, 30%. Okay, so let's just do it. 0, 10, 20, and then 30. Okay, so I'm going to apply this percentage change to the price per unit and also the cost equipment. So right here, I'm going to plot in a 0%, and I'm going to change the cost equipment from a solid number to the number we had before times 1 plus this percentage. Okay, so what I'm going to do is I'm going to replace each of the 7 numbers to this 0%. For example, if I put a negative 30% there, then I will see my cost equipment got reduced, my NPV would increase. If I put 20%, you will see my cost equipment would increase, and then my NPV would drop. Do you see that? All right, so let me just mark it in yellow. So I'm going to use data table, because if I just keep replacing 0% and all the 7 numbers, I need to record my NPV 7 times and copy paste it 7 times. That's really a lot of work. Okay, so rather than that, I'm going to use data table. So it is under data, what if analysis, data table. Before I reach that far, I first need to finish defining the sales. So first of all, I want the NPV here to be linked to wherever my result NPV is. Okay, and then I can just put a name of it, just the cost of equipment. Right, but it really does not matter. I can do it later or just leave it blank, so it does not matter. So what I'm going to do here is I will circle all of the sales, of course, including wherever I got an NPV, and then I do data table under what if analysis. All right, so the only thing I need to click is this 0%, right? 0%. It is a row input cell instead of column input cell, because all the numbers who are replacing the 0% is in row. Okay, they are in a row, not in a column. So I put a row input cell. All right. The idea here is to replace each of the 7 numbers to this 0% and record the NPV. Okay, so just hit enter. All right, so then I'm done. So this would be the corresponding NPV the Excel generated for me. Okay, so that's for cost equipment. So if it's a 0%, that's my original NPV. If cost equipment goes down, that's good, right? Because my NPV would increase when the cost is lower. Now I'm going to do the same thing, all right? Going to do the same thing for the water price or price per unit. So let's say water price here, just copy paste, and then I want the start cell to link with my NPV. Once again, I'm going to use the same idea of replacing all the percentage to a water price. So I'm going to create a 0% right here, and then I'm going to change the setup water price from $4 times 1 plus this 0%. All right, so later on, I'm going to change it to 10%, change it to 20%. You will see my price changes, and also the NPV would change. Okay, so now let me just do the data table, hit data, then what if analysis, data table, and then the rows should be put right here. Okay, so row input cell just as before. So these are my NPVs under different water prices. Dollar figure. So if my water price drop by 30%, I'm having a loss. If water price increase by 30%, I would have a positive NPV. All right, so after you get all the numbers here, I want you guys to create a chart. So you need to insert, and then I want you to insert a chart. Let's say this is a scatter with straight lines and markers. Before you do the chart, make sure you have just click on a blank cell, okay? A cell with no data at all. And then you do this chart creation. All right, so you need to define two series of data, all right? And the first one is you need to add one series, okay? And this is called a cost equipment. The X values would be the percentage of the changes, okay? And the Y values would be the NPVs responding to those changes, okay? So that's a cost equipment. Now you add another one. This time is called a water price, and the X values would be the percentage again, and the Y values would be all the dollar figures for NPVs. Okay. So you have finished this chart. I want you to click on the chart, and you will see Excel will pop up this quick layout. I want you to hit the first layout, and this time is called a sensitivity analysis. Okay, sensitivity analysis. And right click on the legend. I personally prefer it to be placed down the bottom. Okay, down the bottom. All right, and then drag it. Okay, to make it more presentable. Okay, so what it shows here is if cost increase, of course the NPV would drop. If water price increase, the NPV would increase. But which one is more influential to an NPV? Well, the most influential one, judged by the slope, is water price, right? Because the slope here is steeper, and this is the green line is a little bit flatter. So that means when water price changed by 10%, it would result in more NPV change compared to the cost equipment changed by 10%. All right, changed by the same amount. So the horizontal axis is change of a variable in percentage, and the vertical axis is basically your NPV. All right. If you want some numerical support, that's easy to do. So in the CAPM analysis, we learned this is a slope function. So the slope here is you're gonna put the y's for water price, and then comma the x's. Okay, so that's your slope. Well, it's a pretty big number. Just to kill all the decimals, that's for water price, and for cost equipment, the slope is for sure lower. So that's the NPVs, comma, and then the percentage. All right. So once again, it's a big number. You can see that the magnitude of the slope is lower for cost equipment. So this is for cost equipment, and this is for water price. Okay. So you see the water price has a slope with a larger degree. Cost equipment has slope with lower degree. So basically that means NPV is more sensible to water price than to cost equipment. All right, so that's your sensitivity analysis. So you can put the table right here. Okay, and I can find the data after that behind it.